Hi, welcome back to another video in this series of learning C++. So today we are going to learn about user-defined data types. So it is lesson number 6 and let's have a look what are user-defined data types. So here in front of you is a picture that demonstrates the different data types in C and C++. So what are the primary data types? Integer, character, boolean, floating point, double floating point, etc. All of these kind of data types are considered to be the primary data types. Now what are the derived data types? Derived data types are such kind of data types which are derived with the help of these available primary data types. For example, here is an integer data type. Now if I talk about integer and array, so this array can be derived by this integer. For example, when I am declaring an array, I say integer array with certain size. So that is derivation of this data type from these primary data types. Okay? And also arrays can be of character data types as well. So this is what we mean by derived data types, that they are derived from the primary data types such as integer, character, boolean, etc. Now what are user-defined data types? This is a new topic for you guys. User-defined data types are such kind of data type that is designed by the user according to the requirement. Okay, so one is class, another is structure, another is union, enum, and TypeDef. These all are user-defined data types. Okay, so there are no restrictions like an array. So an array has a restriction that it is a homogeneous data type. For example, an integer array can store only integer elements. A float array can only store float elements, and a character array can only store character elements, and so on. But in user-defined data types, we define and we design the data types as per our requirements. So let's have a look at the definitions of these user-defined data types. A structure is a user-defined data type in C or C++. A structure creates a data type that can be used to group items of possibly different types into a single type. So let's have a look, what does it mean? For example, if I tell you that you have to store the name, roll number, and marks of a student, let's say all of these three details have to be stored in one data type. So it is impossible to achieve it with the help of even arrays. If you think of designing a two-dimensional array in which you will say that each column will represent different kind of data. For example, the first column is for name, second column is for roll number, third column is for marks. As we discussed earlier, that arrays are such kind of data types that it only allows you to store only the same kind of data. Okay, so for example, if you design a two-dimensional array for name, so it will just only hold character or strings. If you design it for roll number, so it will only store roll numbers like integer. And if you design it for marks, it will only store float data. So it is not achievable with the array. So what we do, we design our own data type. So we define structure data type by using a struct keyword, and you can name it whatever we want. So we are learning, so we will just name it test. Now within this test, whatever you want to declare, you can declare. For example, you can say that I may have the name of student. Okay, so name will be a character. So let's say name will be 20 size character, and we will have an integer a here. Let's say integer roll number. Okay, then let's say we have float of marks. So this is how you declare the struct or user defined data type struct with this syntax. So what we just did is that we have designed our own data type with our own required primary data types like character, integer, float, and you can add more to it as well. Now let's talk about how can we assign values to these. Now let's talk about that how can we assign values to these variables within our structure. Okay, so this is called structure and these are called member variables of structure. Okay, so let's have a look. One way to do it is that first of all you will write the name of your defined structure and then another variable just to declare the structure. So what is this syntax? So for example, when we are declaring an integer variable, so we use like integer, that is the data type, and we say a, so that is the declaration of integer data type. So same is the case here, that this test shows the data type and this t1 shows this a variable. Okay, so you can have multiple variables, so you can say t2, t3 or whatever name you want to give it to the variables of your defined data type. So let's say if I declare a t1, so what I can do is I can have this syntax. So for example, I can write the name, I can write the roll number 1122, and I can write the mark, so 89.6. So what I did here is that I declare the t1 and then I initialize with the value. So the compiler will automatically know that the first value is going to be for the first variable, the second value is going to be for the second variable, and the third value is going to be for the third variable. Now let's say we want to print this data or we want to perform a certain operation. So how can you do that? So you will write t1, the name of your variable, and the dot operator. So as you write the dot operator, the compiler will automatically suggest you what the member variables are available in our structured data type. So for example, if I want to print the name of the student, so I will say just character name and we will just end it. Okay, then we will access t1 dot roll number and then see out. We will now access t1 dot marks and endel. Okay, so let's run this program. So as you guys can see that we have successfully accessed the name, the roll number, and the marks in our structured data type. So this is how you can design or define your own data type, whatever you want to put it in it, so you can, and you can access the values, the member values or the member variables of structured data type in this manner. So you can perform some mathematical operations with it as well. Now let's talk about another way of initializing values to the member variables of structure. So this is going to be the same as we are doing for printing out these variables. So let's have a look. So first of all, what you will do is that you will just declare it and then you will just, I'll just copy this for now. And instead of C out, I will write C in. So I'll write C in and then C in and then. So this is the same thing that we have been learning from the beginning of our journey, that how we can take the input from user. So this is the same. The only thing that is new for you guys is this dot operator. So this is how you can access the member variables of the structured data type. So let's have a look. Now what I will write is that name, and I'll write 1122 roll number, and I'll write 89.6. And as you guys can see that we have successfully took input from the user, and we have successfully printed out the results as well. So this is how you can define your own data type, and this is how you can take inputs from the user, and this is how you can print those inputs as well. So this was a little introduction about structured data type as well, and we will learn more details in the further tutorials, but let's now introduce other user defined data types here as well. So here is another user defined data type. Just like structures, the union also contains members of different data types. So the main difference is that the union saves memory because union members share the same storage area. Let's have a look. What does it mean? For example, I will define the same kind of data structure that I just did for the structure variable. Okay, so we just did the same thing, just the keyword has been changed from struct to union. Now let's talk about um, taking input from user. So for example, if I tell you that you write this T1 is equals to, we are going to have the same approach for the we are going to have the same approach for the union as we did for the structure. So let's see what happens. We will have name, we will have a roll number, and we will have 89.7 as well. And let's run this program, and I hope there will be an error. Yes, there is an error. Why there is an error? Now let me tell you why there is an error. As I told you that I am expecting an error in it. So how did I knew that there will be an error? So here is a main key point that you should read. The main difference is that the union saves memory because union members share the same storage area. Okay. For example, if I have these three variables within the union, and the greatest of them all is, let's say, integer or float. For example, integer take 4 bytes of memory, and float also take, I guess, 4 bytes of memory. And this character name will take how much of memory? So it depends. So it will, according to this size, it will take like 20 bytes of memory. Okay. So now let's print the size of our union, and let's see what is going on. So if I say size of union, not union, test. Okay. Now let's print the size of it. C out, and we will print the size of it. So as you guys can see that we are getting 20 as our output. Why? As I told you, the greatest variable of all of them is the character variable. So it will just take the place in memory based on the greatest member variable available there, greatest with respect to its size. Okay, so this is how the union works. So it means that once you have initialized the character array, so it will just print out the result. After that, you will it will take input from you and store it in a roll number. So before you store it in a roll number, it will wipe out the previous data. Then after that, when you take input from user and store it in a float marks, then what you will get, that wiping out all the previous data and storing the data in the same location. But let's have a look. If we have a structure here instead of union, what size do we get? So we get the size of 28. So this shows that the structure is giving separate locations in memory for this, and for this. But what union is actually doing, union is actually storing the data in the same location again and again. So what happens when you try to initialize each and everything at one time, it will give you an error. Okay, so let's say we want to take input from user. So in case of union, can't just take each and everything at one time. Okay, so what we will do is that we will take input from user one by one. Okay, so C out, first of all we will say that C in, and we will say T1 dot and we will take input from user as name. After that we will print C out T1 dot name. Okay, then we will take input from user T1 dot floats, and then we will say C out T1 dot float, and then we will say C in T1 dot roll number, then C out we have got T1 dot roll number as well. So why I am taking first input then printing out? As I told you earlier, everything is done at the same location, so I just can't initialize each value at the same time. So I have to assign it a value and then print out, then I have to assign, then print out. Okay, so let's have a look. I'll just do this, and so let's go now. Now as you guys can see, there was no error. Why? Because we are doing everything separately. Name, so name is printed, roll number 1122 is printed, and 89.7 that is also printed. I guess, what's that? Why we are getting 89 only? Okay, so we just changed the sequence. Roll number is at the end, so we will say name, we will say 89.9, and then we will say 1122. Okay, so we have successfully took input from the user and we have printed out or perform any kind of operation. But what if you want to take all the inputs at once? So let me just demonstrate you. So let's see, copy, and we will just paste it. So let's say copy, and we will just paste it over here, and then we will say take input of user, copy, and we will just paste it over here. Okay, let's remove all of these or just comment them down. Okay, now what I am doing, I am taking all the inputs at once, so it means that I need separate memory locations, but in union it is not possible. So let's have a look. It will not give you an error, but there is something else going to happen, so keep watching. Okay, so let's say name, let's say what is the second variable? Second is mark, so we will say 89.7 and 1122. You will only get the printing of this 1122. As you guys can see, the only valid data that has been printed is a 1122. All the other stuff is the what you call it, raw values. Okay, so it is something from the memory taken out. It is not your value because you have initialized it with what? Name 89.7. So it should be printing name in 89.7. What just happened that when you took the input from user for name, so it just initialized name to the name variable. Then after that, when you move on to the float of the marks, so it removed the name from the memory because it wanted to save the float marks in the same location. So you got input from the user 89.7, that's all right. Then when you moved on to your third member variable, what it did that it wiped out all the data previously available at that location because it wanted to save the 1122 at the very same location. Okay, so this is the difference between union and structure. But if you do this with the structure, you will not get any kind of error or any kind of raw value. So you can take values separately and print them all. So let's have a look. And 1122. So this is what you can achieve with structure, and this is what okay, so this was a little bit difference explained between structure and unions as well. I hope you guys got the idea what is the structure, what is the basic difference between structure and union. Okay, so union saves your memory because it restores each and everything, each member in the same location, while structure gives each member variable different boxes or different places to store the member variable values. Okay, so this is just to put in simple words. Now let's talk about enumeration. Enumeration is specified by using the keyword enum. It is a set of named integer constants that define all the possible values a variable of that particular type can have. Let's have a look at the enumeration. So the syntax and the purpose of enum is quite different from the purpose of union and structure. Let's say you have enum and you give it the name of days of week. Okay, so when you say days of week, and let's start the days of week from Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So these are 7 days in a week. Okay, so when you print the days now, so let's say you say Monday, you will get 0 at the output. You will get 0 at the output. So what enum is basically used for, that whenever you want some kind of variables like days of week, months in an year, such kind of stuff, and you want to represent each day or each month by an integer value like 0, 1, 2, 3, etc., you will use enum. So now whenever I write Monday, it will print me 0. Whenever I write Tuesday, it will print me 1, Wednesday 2, and so on. Okay, so but if you want to change the values, you can do that. So when you say Monday is equals to 1, now the Tuesday will be 2, Wednesday will be 3, Thursday will be 4, and so on. And for example, you want to have a customizable increment, so you will have to do it explicitly. So 5, then you will say 10, because in enum everything is incremented by 1 by default. Okay, so this is the concept of E1. So let's say how can we utilize this concept. Let's say if I want to perform different kind of functions in different scenarios. I want to perform something on Monday, then I want to perform something on Tuesday. So how I will do it? Let's say enter the number. Okay, enter the day number. Okay, so day number, and let's start Monday from 1. Okay, so I'll say integer a and then C in a. Now let's apply switch case. Okay, so switch a, and I say case when a is equals to 1. This means print all of this. I am in Monday. Okay, after that break it out. Okay, so break, you guys already know this syntax. So case 2, C out, I am in Tuesday. Okay, and break. And you guys can do it for the other days as well. Let's say this, instead of I am in Monday, you are performing an exercise. Okay, instead of I am Tuesday, you are going to attend some sort of meeting. Okay, so these are some activities that you want to perform based on the input. So let's take input, enter the day number. For example, I am on Monday, so I'll say 1, so I am in Monday. And if I say 2, that means I am in Tuesday. So you can redesign the switch case for these other days as well for practice purpose. So this was the basic introduction to the enum. So what enum does, that it assign each variable some integer values. Then when you print those names within your compiler, the compiler will see them as the integer values, not these huge names like instead of Monday, Tuesday, maybe you wrote like January, February, March, April, such kind of months or anything else. Okay, so the compiler will see them as an integer values rather than seeing them in Monday, Tuesday, Wednesday. So for example, if you had to achieve this same this same operation with the help of, let's say, string. So you say string Monday is equals to 1, and then doing all the other stuff as well. So it would be very difficult to do it. So the enum gives us a this functionality and facility of assigning some integer values to our variables. Now here is another user defined data type that is called TypeDef. So one can define new data type names to the existing ones. How? Let's have a look. So in just simple words, so in normal routine, what we say that integer a. So what we just did, that we have declared a as an integer, or for float I'll say float b. So what I did here is that I have declared b as float variable, and so on other data types as well. So what data type def does is that you can rename this float. So type def, okay. So you will say type def, and then you will use, let's say, float, and you will give it another name, my float. Okay. Now let's say I write my float and b. Okay. So this b is now a float variable with the name, with the customized name of my float. Okay. So let's store some data in it. Let's see, does it work or not. B is equals to 89.9, and we will print out b. See out b. Okay. So it's working. So what you can do is that you can rename already pre-existing data types like float, integer, string, etc. with your own customizable name. So let's do it for the string as well. Let's say string. Okay, string, and I'll say my string. Okay, my string, and I'll say my string here. Okay, and then I'll say hello instead of something numerical value. So as you guys can see that I can customize the name of strings as well. So this was it for the user defined data types, that you learned about the user defined data types in C++. Let me just give you a quick walkthrough that what we learned in this. So we learned about structures, its syntax and its uses. We learned about union, its difference between structure and union, and its syntax and uses. We learned about enumeration, and we learned about TypeDef as well. Why I left out class? We will study class in very detail in a separate video, because we will be using class very oftenly in our OOP. Okay, so for that purpose I will teach the class in a different tutorial video, in a different lecture. But for now, you practice on structure, union, enum, TypeDef, and if there is any question, you guys can let me know about them. Okay, and we will recap this structure when we are learning class, because there is some relation between class and structure as well that you guys must know. Okay, so this was it for this video, and I'll meet you guys in another video. So thanks for watching.